the University of Washington Computer Science and Engineering Distinguished Lecture Series.
It's great to have you here today. Thanks for joining. I'm Ed Lazowska from Computer Science and Engineering, and it's a real pleasure to introduce Hadi Partovi. Hadi is a guy who can't hold a job. He graduated from Harvard, went to Microsoft, spent the 1990s there working on Internet Explorer during really the explosive growth of the World Wide Web and Internet Explorer. In 1999, after IE5 shipped, he headed off to do a startup, Tell Me Networks. In the way these things work, Tell Me Networks, about 8 years later, was acquired by Microsoft. So he found himself back working for the man again at Microsoft. After a year of running the MSN portal, he left to found a second startup, this one with his brother, Ali. iLike, some number of years later, was acquired by MySpace, actually founded by a UW alum, curiously enough. After that, Hadi spent time as an angel investor and advising startups. So after all of that, several years ago, he launched into his sixth career, which has, from my point of view, been the highest impact one, and that's Code.org. So the idea of Code.org is to make sure that every school kid in America and around the world has the opportunity to study computer science. And there are a large number of things they've done. I think Hadi will describe some of them today in the course of his talk. One of the most visible, sort of the PR angle of this, is the Hour of Code, which last year was during Computer Science Education Week. And of course, the audacious goal was that every student in America would spend 1 hour programming. That wasn't conceivable, but more than 20 million students did, including more women and underrepresented groups than in the entire 50-year history of the field, right? And 25 million more, you're up to nearly 50 million, I think, participants in sort of Hour of Code now. So it's really remarkable. Many people have worked for many years to try and move the needle on exposure to computer science and interest in computer science. And Hadi and Code.org, building on what many others have done, have been the people who have finally moved the needle. So a political angle of this is getting states to grant academic credit, science or math credit, for AP computer science. When Hadi started, only 10 of the 50 states granted that credit. A little more than a year later, 25 of the 50 states, including Washington and I think most recently California, grant academic credit for computer science. So amazing progress, and it's great that this really sort of impetus for growth of computer science is coming from the state of Washington, somebody who's spent his career here. So Hadi Partovi, thanks for being here today.
Thank you very much. So I didn't go to school here, but I've spent enough time with Ed that I feel like an honorary UW alum from the amount of time we've spent together. In fact, my sort of seed discussion for starting Code.org actually was a lunch with Ed, I think 2 years before the actual effort started. It took like months of getting him to finally meet with me because he had no idea why some random guy wanted to talk to him about this. So I had no background in computer science education. But that conversation has led to a whole change in my personal life and what we do. So I wanted to talk about something that is only loosely related to Code.org. The title of the talk is more about how you can change the world with technology. And the reason I'm giving this talk is less about Code.org. It's frankly partly to promote my work at Code.org, and I've spent 5 slides on that at the end. But it's actually more to impart career advice that I wish I had gotten when I was going to school. And I'm assuming that some of the people here are seniors or juniors trying to figure out what they want to do next after school. And basically, I want to pass along what I wish somebody had told me when I had been a senior or junior when I was in college. And just to repeat my background, Ed read this off, but if you joined late or missed it, I was an immigrant to this country, and I came here with very little in terms of my family means. I was very lucky to basically teach myself computer programming at a time when schools didn't teach it. And I learned it on my own when I was growing up in Iran. And I ended up becoming a CS major in 1994, and basically have had a fantastic career in tech, particularly highlighted by getting a chance to invest in 4 different companies that all became multi-billion-dollar successes. But for me, really, the best thing I've done is what I'm doing at Code.org, which is basically 20 years after graduating, I've finally figured, what my calling in life is. And what's, for me, particularly been ironic is, in this country that I've immigrated to, 30 years later, after coming here, we teach less computer science than the country I left, Iran, which is like a relatively developing country that's gone through multiple wars and revolutions and actually has a better education system when it comes to technology than here. But so if I dial back to when I was graduating out of college, actually, before I jumped to my college, I also had one other lesson that I almost always give this first lesson to students, especially to male students, which is how many startups does it take to lose your hair? I'm a personal experiment in this, which is 0, 1, 2, and 3, so I'm now bald. So if you learn nothing else from this, it's that doing startups and starting new things is difficult. And the other lesson is that the same tuxedo can last you for at least 2 decades. That's my one point of humor here. But I want to go basically to the time when I was graduating from college and what I was basically looking for out of a job or a career or so on. And I had 2, or really 3, primary goals. The first was to make money. And I know there's some people here who will choose to go through a life of pure academia for its own purposes, but most people, I think about how to get a job and where does that take them and how much money will they get at the end of it and so on. And the second was, being a Harvard grad and close to going to academia, I wanted to solve hard problems, and that was really a big motivator to me. The third was to not be single for the rest of my life, and this was well before Tinder existed, and being a computer science major was probably actually number 1 among these 3 problems. But to focus on making money and solving hard problems, which was basically the way I looked at everything I could think about doing, it was a really difficult thing to try to do both. And when I was graduating from college, solving hard problems meant deep algorithmic challenges. And whether it's the challenges of back then or now, what I would consider hard problems are things like trying to solve the P equals NP thing, or at least coming up with heuristics to get polynomial time solutions to NP hard problems, or writing a new compiler for some new hardware that comes out, or trying to beat encryption algorithms faster than the people who are creating them. And these are basically sort of the research end of the hardest problems in computer science. And meanwhile, if you look at how you make money, the fastest money-making things that are out there have almost nothing to do with solving what you call hard problems. It's creating the next Instagram, the next Snapchat, et cetera. Most of these are basically very small variations of each other where, instead of a message, you're sending an image, or instead of an image, you're sending a self-destructing image, and there's hundreds of startups that are basically trying out every variant of these things. And the good news for the people who are successful at those is that 1 out of every 1,000 of those startups ends up becoming $1 billion success. And there's a lot of allure to basically writing a simple app that somebody could have done in 4 weekends of work and then making billions of dollars. What you miss is that for every 1 startup that actually captures that success, there's at least 100 that went the round of PicPliz, which you may not remember, but PicPliz was Instagram before Instagram that did literally the same thing, but with like slightly different viral inviting and a much worse name, which I don't even know how to pronounce it. But there's many of those, many PicPlizes for every Instagram. And when you create the PicPliz of the world, not only you have this sort of sadness of like, well, you could have been Instagram, but you didn't make any money, but also there's not nearly as much of a sense of really having had an impact on the world. So for me, the problem has been, can you make money and at the same time work on solving hard problems? And for me, really that I've learned that the important thing is not to think about solving hard problems, but to solve important problems. And I've shifted from my college mindset of hard problems being just the algorithmically hard ones to hard problems being the ones that if you talk about to regular people, they're like, oh yeah, that's a really hard problem. So the initial hard problems I threw out there were ones that you basically need a CS degree to even understand what I was saying. Most regular humans don't know what polynomial time anything means. That just is mumbo jumbo. But truly important problems are the ones that regular people think of as major problems and that nobody's solving. And like, one day this should go away because the human race is moving forward, but it isn't happening. So, and we're now living in a world where technology affects every single field. When I started getting into it, or older folks around the room, computers that's what a computer looked like. And computer programming, involved writing code for something that looked like that, or actually a slightly bigger, bulkier, less fancy looking version of that. But we're now living in a day and age where everybody has a computer in their phone. They have computers, they wear computers. They have computers, like multiple of them in their car, et cetera. And so you see medicine is getting impacted by technology. Energy is getting impacted by technology. Space exploration, entertainment, transportation, even crazy things like contact lenses that you put in your eyes that have computers. And in this world, the important problems of today's world aren't just things about solving algorithms. They're things like we have a looming energy crisis. We have a looming water crisis. And along with those, there's soon after a food crisis. Public safety is a problem. You see things like Ferguson, Missouri, and sort of the riots that happened when that happened. And there's going to be another round of riots when the guy who got shot by the cop gets not indicted, and then people get upset. Our democratic system in this country doesn't feel like it's working very well, and we're like the bastions of democracy in other countries that don't even have democracy. It's an even worse problem. The rich-poor income gap, these are all basically some of the hardest problems in the world. But these actually problems they're both important and hard, but if you look at them, they're all problems that technology can solve or at least address. And for me, I hope to inspire at least two of you out there to think about looking at problems of this scale and thinking these are actually problems that as a computer scientist I can go and tackle. And the reason I say that as a computer scientist, there's two reasons. One is computer science and technology gives us the ability to write code that you press a button and then it becomes a million machines run it or a billion machines. Computers basically are the only type of thing we have where you do something once and then you ask it to do it a billion times and it just does it. But the other thing is if you're a computer scientist, you have in your nature a greater level of creativity and sort of empowerment than most other disciplines teach. One of the few disciplines is computer science is a discipline where the core act is of creating something that has never been created before. And many other disciplines are studying things that people have done in history. And if you have the empowerment of a computer scientist and the mind of an entrepreneur, you shouldn't limit yourself to the world of traditional tech startups and thinking your canvas should be the whole world. So I actually want to go through some examples of companies that are addressing those problems. As a sidebar, before I go through a list of companies that address some of those problems, a question I get asked all the time is, since you've been lucky enough or successful enough to invest in multiple companies that were big successes, such as Facebook or Dropbox, how do you actually do that? And I want to share, for me, the two ways I predict success. And this is whether it's predicting success of a startup I want to invest in or predicting success in a company that I want to join. And there's two parts of predicting success for me, one that's hard and one that's easy. The hardest part of predicting success of a company is identifying really good people, like not just the top 5% or the top 10 percentile people, but the top 0.1 percentile people. And you're lucky to go to a good school where you're working with good people. Any of you who've gone through an interview process at a Google or a Microsoft or a Facebook know that the grilling act of interviewing people, what they're trying to do is to basically identify the good from the bad or the very, very good from the very good. But identifying truly successful, truly smart, high caliber people is the hardest part of predicting success. And I was lucky to basically meet one of these three guys when they were graduating from college, or not graduating, but exiting college, almost with a degree, to be able to get involved with their company at the early stage. And people like Mark Zuckerberg or Bill Gates or Larry Page are like the standout examples of entrepreneurial success. But I was also lucky to go to school with Tony Hsieh, and we were on the Harvard computer programming team together, which then led me to invest in both of his subsequent startups, both of which were incredibly successful. Or I was lucky to meet Arash Ferdowsi, who was an MIT grad that you may still not have heard about, but he basically was the co-founder of Dropbox. And for me, identifying people who are basically at the absolute top of their game is the most important, difficult challenge of being an angel investor or doing anything, frankly. But the second and much easier part, and this is relevant for the rest of what I talk about, the second much easier part of predicting success is looking for existing traction. So if you see a graph that looks like that, that's Facebook's growth or Instagram's growth. or Dropbox's growth, this is easy. It is very easy to compare a graph like that and see that it's kind of going up and to the right versus a graph that doesn't look like that. And I want to point this out because so many people can obviously see those graphs and say, yes, of course, no-brainer, that's success, and then don't apply that test when they are graduating from college and some startup wants to recruit them. What does the graph look like is something you should be asking any company that considers hiring you. And if that company is a more established company, the graph has a sort of a knee in the curve where it stops growing like that. Or if it's a very under-established company, it's so far back in the curve that it hasn't had the upswing. And this is relevant because if you're a senior graduating from UW, from the computer science department, you should have your pick and choice of what company you work for. You're much better off joining somewhere here than after the curve has slowed down, and Facebook is now kind of slowed down and it's like that. And you're also better off compared to joining here, because when you're joining over there, it's basically a complete blind luck, and maybe you're right, but most likely you're not, and you don't need to take that chance. So getting back to the hard problems I want to talk about, I'm just going to go through these 4 problems. These aren't the only important problems in the world, but these are 4 problems that I care about and that I've actually spent my time identifying efforts or companies that are working on them to see how I can help myself. And I want to share sort of companies that are tackling these problems using technology as the way they're going about them. So the first one is the looming energy crisis, and along with it, the water crisis, which, as you know, the world population is growing, and there's no clear end in sight in population growth, and there's definitely an end in sight in energy, water, and the amount of carbon we can stuff into the atmosphere. And so sustainability of the human race relies on sort of addressing these things. There's a company called O-Power, and I met them when it was literally one guy and an idea. They actually didn't have a name yet, so the investment I made with them was a blank check with a sort of enter name of company here, once you figure out what to call it. But what these guys do, they're a software company that tries to reduce your usage of your utilities. And they started trying to get your use of electricity down, and then now they're getting your gas usage down, and next they're going to reduce your water usage, so that basically as a consumer household or as a business, you use electricity or any of these things less. And there's a natural question of, well, how do you get somebody to use less electricity? And they started the easy way, which is basically comparing your usage to your neighbors. And this is an extremely simple psychological thing. It basically said, hey, you spent this much on your electricity bill. Everybody in your neighborhood with a similar size house spent less than you, and they saved roughly like $7 a month on their bill. Here's where you are, here's where your neighbors are. And simply comparing you to your neighbors, whether you were less or more, resulted in you using less energy because you started being more aware of it. And this was an incredibly simple idea for them. They've since then done a lot more to actually analyze in close detail people's usage of electricity to figure out specifically, like, at 5 p.m., your thermostat is at this setting and you should do something different. Or you're, heating your oven too often, or so on. And the way they do that is they basically get these crazy charts of all the sort of electricity usage of people in a region, and then use data analysis to basically see, oh, you're one of these curves, which means this is what your usage looks like, and one of these other curves, which means you leave the house all day, but you've left the heater on, or things like that. And so they actually analyze individuals' electricity usage, match them into one of these behavioral groups, and then give them targeted advice about how to reduce their energy usage. What's awesome about this company is, first of all, they're now a public company, so they've been successful enough to go public. In less than 7 years, they've saved 5 terawatts of electricity. They've reduced 7 billion pounds of carbon that should have gone into the atmosphere but didn't because nobody was using the energy that would have generated that carbon. They've helped people save more than $500 million off their energy bills. And also, lastly, this has basically been the chart of their revenue growth, and I mention that because when you see a chart like that, you don't need to question, is this company successful or not? Everything else you can question, is it a good idea or a bad idea? But they also have the traction that basically shows this company has basically solved the problem and is on its path to future growth. In a completely different area of public safety, I want to give a different example of a company that's using technology to address public safety. So this company, evidence.com, is focusing on mobile and wearable technology for law enforcement. And their goal is basically to prevent the next Ferguson, Missouri, where some guy gets shot by a cop and nobody knows what happened, and then there's like riots and racism and all that stuff. And their core product is basically wearable cameras for police officers to wear with a back-end server that stores all the digital evidence so that whether you got pulled over by a cop or you got shot by a cop and everything in between, there's digital evidence that said exactly what happened rather than an unknown he said, she said. And they have incredibly proven results that when police officers wear cameras, the same exact officer wearing a camera is 60% less likely to have any degree of violence and 90% fewer complaints against the law enforcement agent. So it's a complete no-brainer that officers should be wearing cameras. The idea that we'd give guns to policemen and not give the camera that causes a 60% reduction in the use of that gun, the camera is cheaper than the gun. But either way, that's their basic business. So anytime I see something like this, my first question is, okay, sounds like a good idea. Do you have traction? And what's cool about it, again, is these guys, this is basically the chart of their actual usage by law enforcement video uploads per quarter. And this is the actual chart of their revenue growth on a quarterly basis. And both of these charts are about 3 months old, so they're actually, the next bar up is significantly higher up the graph than the continued thing. And again, I'm mentioning this, again, not because this is the be-all, end-all company, but just to show that charts like the growth I showed you of Dropbox or Instagram are possible in a completely different space that you wouldn't necessarily have thought of. This, by the way, happens to be a Seattle local effort. So for those of you who aren't looking to start startups and are looking to join them, it is a great change the world effort that's located in our backyard. A completely unrelated problem is sort of our broken democratic system, whether you look at the US or whether you look at countries that don't even have democracies. There's a company that I'd hope to invest in that I'm not involved in yet, but that I'm a big, big fan of, called change.org. These guys basically are a system that makes online petitions really easy and actually connecting petitions to real change. Anytime you've actually signed one of these petitions online, usually you sign your name and give your email address and get 100 emails a month for the rest of time, but you don't know what actually happens from it. Change.org doesn't just provide a petition, it connects the petition to actually changing the system. So they see what has traction, and then they actually make sure that somebody acts on it. And they help effectively give the little guy a greater voice in creating change. So as an example, this is a petition that just got launched in the last 6-7 weeks, which was taking a particular Ebola drug and vaccine research and trying to get the FDA to fast track it. And it's the perfect example of something that, like, should the FDA fast track Ebola research? Yes, but like the government doesn't always work the way we'd like. It might not even get there, or if it does get there, it might not get there quickly enough. And this is dealing with an emergency. So this petition, within weeks, basically got to the point where it had 150,000 supporters in a very, very short period of time. And the FDA basically fast-tracked the company that helped create this petition to get their drug moved farther along in the clinical trials and so on. What's also neat is Change.org, as what appears to be a nonprofit, is actually a for-profit. And although their revenue numbers aren't things that they disclose, they have a very nice-looking curve of growth as well. So again, this is an example of a startup that isn't trying to sort of make money as its core goal. It's trying to fix democracy as its core goal, but it's actually making plenty of money doing it along the way, which is fantastic. The last problem I want to talk about, which is probably the hardest one to deal with, so the two examples I have on it aren't addressing the problem directly. One example is basically addressing the rich-poor income gap. There's two ways of addressing it. One way is just taking money from the rich and giving it to the poor, which doesn't work very well for the long run. The real way to address it is to basically address opportunity and to give people a chance, if you don't have anything, to make it somewhere. And there's two different examples I want to talk about that basically help address opportunity. One is access to capital, because access to capital historically has not been limited and democratic and equal, and it should be limited not just by your connections or your race or your gender, but by your ideas. And for me, one of the perfect companies that is basically helping give people access to capital is Indiegogo, where basically any idea that you have, if you want to kickstart it or start it, whether it's a Kickstarter style gadget, whether it's a movie, a restaurant, a game, a nonprofit, or even a startup, you can basically fund it if the idea is good enough and if enough people get behind it. And Indiegogo, you've probably heard of it, similar to Kickstarter. Both of these companies are in a similar space, but Indiegogo is tackling it more broadly than just gadgets. And what's cool about them also is they have a perfect curve like that showing continuous growth, and again, is showing traction that most startups don't have, and most big companies have made it beyond that growth potential. What all of these companies I showed you have in common, which are things I would urge you to look for, is first of all, starting by trying to solve a truly important world-changing problem, not just the next sort of Snapchat meets Flappy Bird. And I mentioned Snapchat meets Flappy Bird because that's literally a startup that did that. It sounds like a joke. If you're familiar with Snapchat, that's the thing where you send messages that self-destruct, and Flappy Bird is like the impossible game where you can't even score 1 point. And somebody made a startup where you send a self-destructing message that the recipient can only read if they score at least 1 point playing Flappy Bird, to then read the message, and then it self-destructs, and then they send one back. Which might have become the next Snapchat, might have not, but my point is, those are not worthwhile problems for a brilliant mind to spend their time solving. And even if you make $1 billion coming up with an idea like that, you're gonna end up having an empty hole thinking, why didn't I do something actually useful? So separate from tackling a big, important problem, the other thing I'd advise is to find an angle for software to make a high leverage impact. And the reason software is partly because if you're here in this room, that's what you're good at, but the other reason is because software is, the leverage you get from software is how you can make a lot of money. Something that involves hiring 100,000 people may have the impact, but may not have the equity return to give the same kind of financial returns of most software companies. The third thing is to make sure there's actually a business model and figuring out how somebody's gonna pay for it. Just to give an example, the company I mentioned, O-Power, that is driving energy efficiency, people regularly ask me, well, how do they make money? If they're getting to use less electricity, who's paying for that? And it actually turns out the utility company is paying for that, which is kind of confusing because the utility company is selling you the electricity. Why would they pay for you to use less of it? And the reason is because the way utilities work, especially things like electricity, is it's not the total amount that you use, it's the peak demand that causes their underlying cost. So if they can basically smooth out your usage and reduce the peak demand, they can save more money than you save. So if they save $10 and you save $5, they actually make $5, which is a kind of a funny way of making money. But basically, O-Power helps the utility company save even more money than they save the consumer, and that's effectively how they get paid. The business model for how you can change the world isn't always obvious, but as long as you have an important problem, software can address it, and there's a business model that will pay for it, those are the things to go after. And if you're looking for a job rather than to start a company, if you're not starting the company yourself, it's critical to make sure that the traction actually looks right. Any of you who are actually interviewing at companies, if they are public companies, look at their stock price, which is the easy thing to do. But if they are private companies, ask them to see a chart of users or revenue or something. Ask them to remove the numbers, but just so you can look at the shape to see, does it look like this or does it look like that? And that's a very easy question that companies are willing to share if you just tell them not to leave out the numbers. The last thing I want to talk about is sort of the second part of fixing the rich-poor income gap and addressing opportunity, which is what I've spent my time on. And my belief is that education should provide equal access to the highest paying careers, and this is my way of effectively helping solve the inequality we have in this country. So I want to talk a little bit about the problem that Code.org is trying to solve. And we're trying to basically improve opportunity in the United States. And there's some very basic reasons behind what we're doing this. The first is the best paying jobs in this country are for computer scientists. So congratulations to all of you who are entering this field. And then the second thing is jobs in software are growing, and yet there are fewer computer science graduates today than there were 10 years ago. So the job graph and the graduates graph are going in opposite directions. the picture in Washington State as an example, there's currently more than 19,000 open jobs in the state today. There's less than 800 graduates that graduated in the field last year, and there'll be slightly more this year, but nowhere near 19,000. And then 62 schools in this state teach computer science, which is like completely busted. And this picture you might say is, okay, maybe it's Washington, we have Microsoft and Amazon, and maybe Washington, California have this picture. The reality is every single state in this country has a picture that looks like this. The numbers are worse in Washington than in other states. Actually, Washington is the worst of all states with these numbers, but they're just as, the relative ratios are just the same. So in Nebraska, in Mississippi, in Alabama, North Dakota, in every one of these states, there's more jobs than graduates and very few schools. So if you look at it overall, this chart on the left shows how much time is spent by students studying computer science relative to all of math and sciences in high school. So of all the math and science studying that happens in high school, there's roughly 2% of that time is spent on computer science. And then if you look at the math and science field of jobs, it's actually now almost 70% of all new jobs in all math and sciences are in computer science. So there's this huge disparity between what our schools are teaching at the K through 12 level versus where the economy and sort of actual value to the country is. If you look at this over a 10-year period, there's over 1 million more jobs than there are graduates if you look at the trend in graduates and the trend in jobs. And these add up to a $500 billion opportunity. And the reason this graph is important is a $500 billion opportunity, that's the size of things like the fiscal cliff or the debt ceiling or these things you hear about Congress wrangling around as like the biggest economic problems facing the country. This isn't one you hear about Congress wrangling around, and yet solving this one doesn't require this like hardcore agreement between Democrats and Republicans and raising everybody's taxes a huge amount or cutting spending or whatnot. It's just about getting schools to teach something using their existing staff. So Code.org's vision and what I've been doing with my life is our vision is that every school and every student should have the opportunity to learn computer science. For us, the sort of first way of getting this done is introducing the field at the smallest bite-sized sort of morsel, which is the hour of code. And the hour of code is basically an idea of getting teachers in regular schools, math teachers, English teachers, history teachers, French teachers, to introduce 1 hour of code in their classroom instead of history or science or whatever it was going to be. And this is a campaign that we organized, but we've had over 100 partners, whether they're for-profits or nonprofits, to basically get behind this campaign to get students in regular classrooms to try 1 hour of code. So this is a slightly old slide. We now are at the point where 46 million kids have tried an hour of code. To put that in perspective, the US has 50 million students, which has been amazing. So this is obviously an international number. We're roughly at 35% of all US students in terms of participation, which is amazing considering this is roughly 10 months old. So it's among the fastest spreading things on the internet, I think. And the other thing, as Ed mentioned, is this is basically the chart after 1 week, where on the right is basically what the hour of code did in 1 week with respect to girls trying computer science, and on the left is the history of the field. So now that's not in terms of total learning, it's a chart of total participation. And I want to make sure that's clear because 1 hour isn't enough to make anybody a computer scientist. 1 hour is enough to basically have them have fun and at least get a light bulb that says, I can do this, and it's not as hard as I thought, and maybe I'll go into it. So it's clearly comparing apples and oranges, but we basically have dramatically increased participation in the field. But then there's this natural question of, okay, after 1 hour, what happens? But we very much as an organization came up with this hour of code idea to convert people into real learning, not just the first hour. So there's 2 things we're doing with courses through grades K through 12. At the high school level, we have a nationwide effort to partner with school districts to basically put new introductory computer science courses in schools that didn't have them before. So we're now in 30 school districts, including all 3 of the largest school districts of the country. We've placed new classes into 300 new high schools. We have 13,000 new students in these classes with 34% girls and 60% African American or Hispanic. To put that into context, this is an introductory CS class. The AP CS class that's been around for 3 or 4 decades has 39,000 students, which is more, but this is a 1-year-old program. But the AP CS class has fewer African American and Hispanic students. So we're very hopeful that after a few more years of introducing this course at the intro level in high schools, we'll dramatically increase the pipeline of kids going into computer science in the field and also significantly shift the ratio of African Americans and Hispanics in the field. And then at the grades K through 8, we have a worldwide effort with an online course that is already in 50,000 classrooms with 2 million students learning basically introductory CS at the K through 8 level, and 40% of them are girls. These things are basically completely sort of side effects of what happens as a result of the hour of code, because our 1-hour morsel gets schools, teachers, parents, and students more than all interested in learning this and interested in learning more. So I have 4 parting thoughts for the group, having talked about all that. The first, I spoke about this briefly, but since you're in a college with a whole lot of students around you, spend the time while you're here learning to recognize good people and to stick with them. So somebody in this room may be the next Mark Zuckerberg or the next Tony Hsieh, and you should try to find who that is. The second is that identifying traction is really easy. So if you're looking for a job after school, make sure to ask the company to show you what their graph looks like. And they don't need to show you the revenue or the actual numbers. You can remove the axes and still look at the graph. The third is, and this is probably the main point of my talk, is to whether you join a company or whether you build a company, have a tech company that actually solves real problems rather than stupid ones. And then the fourth is to help support the Hour of Code, which is our campaign. And the way you can do that is, if you recently graduated from high school, go to your favorite high school teacher and ask them, are they doing an hour of code in their classroom? And if they aren't, have them go Google it. I want to close with a short video which summarizes the work we've been doing with the Hour of Code, although I'm not sure if the audio in this will work.
Hour of Code.
The Hour of Code. Todos lo pueden hacer.
या प्रोग्राम या कोड من 42 خط کد
Your teacher says you guys are into it.
We are. It's very awesome.
Code.org has partnered with 30 public school districts across the country, including New York, Chicago, and Denver, to provide lessons in teacher training and writing.
The largest education events in history.
Organizers set what they called an ambitious goal of reaching 10 million students this week. Almost 15 million signed up.
This week, I'm proud to join the students, teachers, businesses, and nonprofit organizations taking new steps to support computer science in America's schools.
They've been so excited about it.
You're learning and you're playing.
I got it.
I ran an hour of code that's easy to do.
They're learning how things are created in a technological world, and that's their world and their upcoming world.
Every district should do, every district can do it.
I'm actually seeing the kids in elementary school start coding, and this is amazing.
I'm so excited! I'm actually gonna code.
You love it?
Yes, I love it.
Is coding super fun?
Yes!
If you can change technology, you can change the world.
I challenge girls in every single country to learn 1 hour of code.
Computer science can unlock the best opportunities in the world no matter where you are.
Please help us get the Hour of Code to 100 million students this year.
And my school's doing it.
So if you have any questions, I'm happy to answer questions. By the way, you can ask questions about startups, about code.org,
Okay.
about investing, about frankly anything.
Okay. I wanted to say I'm glad you've identified some really good hard problems in the world. My question is it not, I'm not sure I understand why, like, say I get a PhD in computer science and someone else gets a PhD in economics. and why it is that I should believe that I'm more equipped to handle the problem of, say, dealing with poverty than someone else. I mean, it feels like you can definitely have good examples, or you can get something like Soylent, where computer scientists seem to like it, and some nutritionists in the rest of the world seem to shake their heads and scratch their heads and go, what are you guys doing?
So I actually don't think it's better to study computer science than anything else. This is a group that is, I think, mostly computer scientists, so given that's what you're studying, I'm hoping to urge you to try to solve real problems with it. You know, the reason I've been promoting code.org, just so you know, isn't because everybody should become a computer scientist or because everybody should learn to code. It's because I believe every school should offer it so kids have the opportunity. And I think every kid should have the sort of basic level of, like, you learned photosynthesis when you're in high school, and you learned that water is H2O, and the CS equivalent of that is what every school should teach. So, but I do think that if you learn how to use software, you have access to means of changing the world that most disciplines don't have because of the agility with which you can build stuff and the sort of flexibility of the internet to get things out there. So if you were an economist, your means to impact wouldn't be just get some 5 guys together and build something and then push it out. It would be writing white papers and convincing politicians to pass laws, which has dramatic change but takes many times 5-10 years of arduous work. And then once those 5-10 years go by, finally a major law gets passed that, whether it's for better or for worse, makes a change. But we're in a field where you can have change dramatically in 1 year. Things like the hour of code, it's been 10 months, impacting 45 million kids. Only technology has that level of fast change. And again, that doesn't mean that's the only reason to go to it, but given you're in it, may as well use it for some good.
You showed the growth rate for every startup except one, that was code.org. How much money do you actually make? What traction do you have?
So the reason I didn't show that is because I mentioned the growth rates in the context of a job, and we're a nonprofit, so we basically don't offer stock options. So we are very successful as far as nonprofits go in terms of traction, and our graphs do look like that. But if you were going to work at code.org, you wouldn't get stock options that have any chance of doing that, so that's why I didn't share those. And it's funny, I wasn't even thinking about it, but the reason I showed those other charts is because if you graduate to get a job, and assuming it's a for-profit, if it's a for-profit tech company, you'll get stock options, and every graduate, one of the biggest challenges they have is, what the hell are these stock options going to be worth? And the most important question is, does it have a graph like that? In the code.org case, the fact that we've reached 43 million kids, our graph, first of all, has a gigantic spike from the initial hour of code last year. So there was like a 15 million user week. And then since then, there's been a curve that looks like this if you ignore the spike. So the spike is an aberration, and we'll have a spike this year as well. But aside from the spike, we have continuous growth. So we have roughly 100,000 users a day doing the hour of code, and 10,000 new students signing up for a full login for an ongoing course, and between 500 and 1,000 teachers a week signing up into our system. So, and those numbers, if we were a for-profit, those are all amazing numbers. Very, very few startups have 100,000 new users a day. But we don't make money from any of it, so it's not as relevant from a job search standpoint.
Thanks.
So I'm interested in what you actually expected from the hour of code. You must have, on one hand, been worried that there wouldn't be a lot of uptake, and on the other hand, be worried about a complete success disaster in which everything melted down. So, how did these 20 million people compare to your expectations?
So we had set the initial goal of reaching 10 million students. And there was actually a very important reason why we said 10 million. Code.org started with a video that was my hobby project, and that video had 10 million views in 1 week. And basically, as I was making the video, people said, well, what's next? And I was like, I don't know, what's next? It's a hobby. And so we put out the video, and 10 million people saw it, and then there was nothing next. And then I was like, shit, we should have planned something to come next with the video. So actually, the genesis of the idea of the hour of code is, could we get 10 million people to do, instead of watching a 5-minute video, to actually try coding to recognize that they can do it. And then if we can get 10 million people to do that, we can have a better follow-through. So we set the goal of, well, if we could get 10 million video views in a week, let's get 10 million students to try an hour of code for a week. And I also said, if you shoot for the stars, you might reach the moon. So I secretly hoped we could get 4 or 5 million, and it was ridiculous. We had 4 million students in the first day. So there was both this like worry of what if we don't get enough, and then what if we get too many? You know, going into it last year, we had in advance lined up a speech by the president and 4 or 5 other major politicians, Google committing to put it on their homepage, Apple committing to put it into every US store, all these things lined up. So it was definitely going to be not a flop. And so actually part of the worry was how to make sure the servers stay up. This was at the time, if you remember, the healthcare.gov website was struggling to stay up with like 5,000 visitors at a time. And you know, it's worrisome, basically, just if we had the Google homepage promoting us and the site was down, that wouldn't work. And if you were actually awake at midnight last year, for the first hour, our site was down, and Google was calling us saying, this is on our homepage. But we got the site back up, and like as soon as we got it up, we had 300,000 students every single hour going through this program, which is amazing.
And I remember seeing you at a party the Saturday at the end of that week, and you looked like you'd been hit by a truck.
Yeah, it was a good week.
So for learn to recognize good people, stick with them, should I also be a good person? If I think I'm not good enough, how can I stick with good people?
By the way, what does good people mean is a tough question. And for me, this is kind of a very broad statement, but when it comes to hiring people, whether it's hiring an employee, whether it's hiring a lawyer, hiring anybody, you look for certain things. I look for basically probably the 2 most important things are IQ and passion. There's a lot of other things you can look for, like integrity or follow through or responsibility. But those are the 2 that I've considered to be the 2 most important seeds. And they're hard to judge. But learning to judge character is a skill you can develop like any other skill. There's no like judging character or judging IQ class that you can take. If you work at a company and you get to be on interview loops, I would sign up for that as quickly as possible and get on as many interview loops as possible in your first job so you can interview other graduates, just because it gives you the experience of trying to see, well, this guy, how do they compare to the last guy? How do they compare to the last guy? And if you do enough interviews of other people, you can get better at recognizing good from bad faster. And it's a lot about trusting your inner thoughts, because somebody's resume may look amazing and, oh, they went to Facebook and Pinterest, but then it turns out they're actually quite bad. And resumes are not at all a great example of how good somebody is. So.
Thank you.
So what advice would you give us as current CS students, maybe who are a few years out of high school, other than just telling our teacher friends and old teachers, or maybe us as a department on, being active in outreach and trying to get, computer science to be more part of the standard curriculum?
Well, the first thing I'd say, since you're female, is to make your voice heard.
Okay.
This is such an overly male-dominated field, and part of that is because just, what it is begets what it is. It's just like a self-fulfilling prophecy, and the way to change that is basically to have the voice of women in the field get heard much louder. So, there's not as many women who speak up about computer science, and we need, since there's 1/5 as many girls in the field, they need to be 5 times louder to start drowning out the other voices. Code.org has dramatically moved that needle. So when our elementary school kids grow up to high school or college, I think we're going to see much closer to a 60-40 balance, or maybe even 50-50 balance. But in the meantime, that's probably the biggest thing I'd say.
Okay.
I think the hour of code is great. So what are you doing to kind of evaluate what happens because people have had that experience afterwards?
So for us, first of all, we're a nonprofit, so as a nonprofit, we have to be metrics-driven to know, like, did we spend everybody's money well? And our donors expect that naturally from us. The first thing I'd say is the hour of code is probably the smallest, sort of the least expensive thing we do. So it's the most visible thing we do. It's what people know us the most for. But in terms of where the money goes, it's like a sort of side effect, like secondary kind of thing. So what I tell our donors is, like, don't even worry about it. As long as it's not bad, it's less than 10% of our money spent is the hour of code. I think it's actually much more than 50% of our impact. But I don't have as high a bar to measure that because it's not where all the money goes. And for us, where the money goes is first and foremost getting school districts to adopt computer science, and secondly, building new curriculum for the age grades that don't have it. And those things we do evaluate. We evaluate how many students signed up for these courses, what's the diversity in those students, how far along did they get through the online courses, and so on. And what the Hour of Code does is it makes it so much easier to talk to a school district that doesn't have computer science. When we started doing this a year ago, we were knocking on doors. School districts didn't even know what computer science is. They definitely didn't know who we were. Now they're like, oh yeah, we did the Hour of Code last year. Our kids loved it. You guys did that? Okay, what do we do next? It just makes it a much, much easier conversation to have.
Okay, one is exposure. That's the Hour of Code, gets the attention, right? A second is curriculum development. And a third is teacher prep, professional development. And what was the fourth?
Fourth is state lobbying.
State lobbying, right, okay. So that is trying to get states to give academic credit for computer science, for example.
Yep. But the Hour of Code is basically helping all those. In fact, we're at the point now where there's numerous states that are going to be competing with each other to see which one of them does more Hour of Code activities, which is such a difference relative to like a year ago when nobody had even heard of the field.
I hope this isn't too technical a question, but you are, excuse me?
Go ahead.
Okay. You are speaking to a highly technical crowd. I was curious about how you guys built out your infrastructure and backend to handle the raw number of people that hit your systems.
Okay. You scared me when you said not too technical question. That's definitely not too technical.
Okay.
So first of all, we're built on AWS, which means at least we don't need to worry about how many computers we need. Yeah. And whether it's Amazon or Google or Microsoft, building on somebody else's cloud makes that much easier. And then the other thing is we have a huge amount of caching. And for our Hour of Code tutorials, we basically did a number of things. I'll just share this. This is a technical group. I assume it's curious. Because basically, we were worried about, we might have 1 million kids, and that's fine. But what if we actually do have 20 million kids? Like, that's actually hard. We had, I think, only one master database. So there's this worry. We didn't go through the effort of basically a multi-master sharding the users and so on. But to maximize just student engagement, we didn't require sign-in or sign up at the front end. To do the Hour of Code, you just come right through and go do it without any information collected about you. So I made sure that we basically would survive if the database was completely in read mode. And then I actually made sure we'd survive if the database was off, which means every single page in our tutorials could be served completely off a cache. A cache off a database query, but if the database query fails, it's off the cache. So, and in fact, there was a period of time when we started where the database couldn't handle the load, so we didn't collect any data for that, like a few hours of time. And it was just serving off the cache. So serving cached HTML pages, that is super duper easy. It's scaling. Writes are the hard thing to scale, and we basically didn't have very many of them, and we didn't require them for the tutorials to succeed.
Thank you very much.
You're welcome.
Great. Let's thank Hadi again, and please join us for a reception.
Thank you very much.